All right, so today, class, we're going to be learning about the area of parallelograms. Remember that area is just the amount of space that a two-dimensional shape or object takes up. So first of all, we need to just determine what is a parallelogram. A parallelogram is a four-sided shape with two sets of parallel lines, meaning they're running in the same direction. And the formula for area, and this is on your sheet already, is area of a parallelogram equals base times height. Now, sometimes a parallelogram has right angles. So I'm going to draw in the right angles here. So what we're looking at is a rectangle on this side. That's one type of parallelogram. And I will show you how it has two sets of parallel lines. Okay, so again, parallel lines are just simply lines running in the same direction. So I see that these two lines are both running vertically in the same direction, and then the other two lines are running horizontally in the same direction. But not all parallelograms have right angles. Some of them look like rectangles that have sort of been squished or slanted, but these are still parallelograms because I still have two sets of lines that are running in the same direction. But notice for this kind, the height is not the diagonal. The height is going to still be the straight vertical line, whereas the base is shown as follows with straight horizontal. So you can turn a slanted parallelogram into a regular rectangle by moving the triangle from one side to the other. So this shows a picture of that. If I were to cut out this blue triangle and move it to my other side, I would create just a standard rectangle. And these two shapes, even though they look different, have the exact same area. So notice once again that the height needs to be the straight vertical distance, not the slanted side. So that's why I crossed out that version of the height. We're never going to use that as the height. So let's look at your sheet now. Number one, which three of these parallelograms have the same area as each other? So the first thing that I want to do is I want to remind myself of my formula. So let's rewrite it here. Area is going to equal base times height. So what I want to do is I want to figure out, okay, well, for each of these parallelograms, what's the base and what's the height? And I've already drawn in some of those vertical lines for you to show the height as a straight vertical line rather than that slanted side. All right, so let's go ahead and calculate these. I'm going to count my base, and I see that my base is 1, 2, 3, 4, 5 units. So I'm going to say area equals 5 times my height is 1, 2, 3 units. So area class is going to be what? 15. Let's make this a little bit smaller just to make sure we can fit everything in here. Okay. And then let's move on to B. B, my area. My base here, I'm going to start down here at the bottom, is 1, 2, 3 units. Now I have to calculate my height. 1, 2, 3, 4, 5. So once again, my area is 15. C, my base is 1, 2, 3, 4. So area is going to equal 4. And my height is going to be 1, 2, 3, 4. So my area is what class? 16. Let's pause for 1 second and just label some of these. So here my area is 3, or not my area, sorry, my height is 3, my base is 5. In B, my base was 3, and my height was 5. And in C, both my base and my height were 4. Okay, let's take a second and look at D. I'm going to use this length as my base. So that's going to be 3. I'm going to kind of look at it sideways. So then my height is going to be 1, 2, 3, 4, 5. So my height for D is 5. So let's scroll down, just make sure we have some space here. So for D, I know that my area is going to be very similar to 3 others. Area equals 3 times 5, so area equals 15. So So the question says, which of these parallelograms have the same area as each other? I want you to circle A, B, and C. The only one that, and D rather, the only one that does not fit is C because that was 16. Question 2. Which of the following pairs of base and height produces the greatest area? All of the measurements are in centimeters. Now for this, all we want to do is show our work because I'm already given the base and the height. So all I need to do is plug it into my formula. So area equals base times height. So for A, I know that area equals 0.8 times 20. So I'm going to plug that into my calculator. 0.8 times 20. And that's going to give me 16. So now I go back. I know that is 16 centimeters. I'm going to have a hard time doing my square here because I'm typing. So for each of these, not highlighters, sorry about that. For each of these, just make sure that you are adding your square because in area, we're always going to use a unit squared. Okay, let's move on to B. B, my area once again is base times height, so it's going to be 0.8. Wow, I'm really messing up here. I accidentally did B here. So let's cross out A and write B. And then we still have to do A. So I'm going back up to A. In A, area is 4. My base is 4 times my height, which is 3.5. So let's plug that into our calculator. 4 times 3.5 equals 14. So I'm going to go back, and I know that area for A is 14 centimeters. And once again, I need to make sure that I'm adding my square. Okay, pause the video, try C and D on your own, look up when you're done. All right, we're going to go ahead and go over C and D. For C, area equals base times height, so area is going to be 6 times 2.25. Plug that into our calculator, 6 times 2.25, and we're going to get 13.5. So if you've got that, give yourself a check, and we want to make sure that that is in centimeters squared. Then we're going to move on to checking D. D, area equals base times height, area equals 10 times 1.4. Calculator, 10 times 1.4, and I'm going to get 14 centimeters squared. So my question that I was trying to answer is, which of the following pairs produces the greatest area of these? It's looking like B, 16, produces the greatest area. So go ahead and circle B. 3. Here are the areas of 3 parallelograms. Use them to find the missing length labeled with a question mark on each parallelogram. This is a great opportunity for us to use variables for the missing length. So what we're going to do is we're going to rewrite our formula using a variable. So I'm going to say area equals, for A, I'm given my base of 5. So I'm going to say 5, and I'm going to leave H because I don't know what my height is. But I do know that my area is 10. So 10 equals 5H. How do I get H by itself? Do the opposite of multiplication, which is what, class? Yes, division. So I'm going to divide by 5 on the right. I'm going to divide by 5 on the left. So what do I have left? 2 equals H. So I know that my missing length is 2. Okay, let's do one more all together. For B, I am given my area as 21. So I know that 21 is going to equal my base times my height. Now, this one is a little bit tricky because my base is actually 1 plus something else times my height. So I'm going to start with my height, and then I have to say 1 plus my base. No, I'm rethinking this. That's going to give me a bigger area than I actually want. Base. So if that's my question mark, and that's 1, you know what? I can ignore that 1 actually, because all I need is this vertical height. That's all I need, which I already have that. So I'm going to ignore this. I don't really need that length. All I need is 7 times my missing base, which I do not know. So now I need to do the opposite of multiplication, which is what again? Division. So divide by 7, divide by 7, and I know that 3 equals my base. So my missing length is 3. Okay, when you do C on your own, there is going to be a number over here that you don't need. You have to decide which one. Pause and try on your own. I hope you realize that the number you did not need was this 2.5, because what I'm looking for is my height, which is 5, my straight line height. So I know that my area, which is 25, equals base times height. I do not know my base, but I know that my height is 5. So then I'm going to do the opposite of multiplication, which is division. Divide by 5 on this side, divide by 5 on this side. So I know that 5 equals my base. So my missing length here is 5. Okay, 4. The Dockland building in Hamburg, Germany is shaped like a parallelogram. If the length of the building is 86 meters and its height is 55 meters, what is the area of this face of the building? Pause, try this one on your own. Right? I know that area equals base times height. So I know here that area is going to be 86 times 55. I'm going to use my calculator. 86 times 55 gives me 4,730. So area equals 4,730 meters. And because it's area, I need to do meters squared. 5. Select all segments that could represent a corresponding height if the side M is the base. Okay. So here is my base M. I know that my height has to be a straight line at a right angle from my base. So right away, I'm going to cross off N. That's not at a right angle from my base. G is not at a right angle from my base. H is not at a right angle from my base. So I'm left with E, which goes all the way up to the top of my shape and is at a right angle from my base. That's one correct answer. F is at a right angle from my base and goes all the way up to the top. J is at a right angle from my base and goes all the way up to the top. K is at a right angle from my base and goes all the way up to the top. So my answers are E, F, J, and K. 6. Find the area of the shaded region. All measurements are in centimeters. Show your reasoning. Okay, so for this one, what we really need to do is we're going to have to figure out a base and a height. And what's tricky is they don't actually give us any of those measurements. So we're going to have to figure all of them out on our own. Let's see how we can do that.